Hi, I'm Eric Edelman, your host, and today we're talking about another show on Down to Earth, and we're going to go into some virtual reality questions and how it might not be related to some of the fundamentals that make up our very universe. In particular, we're going to be digging our way through what is called the simulation hypothesis. So, what is that exactly? Well, I'm going to leave you hanging for just a little bit, and first we're going to take a bit of a peek out into the cosmos and get our bearings. So tonight we're using the Slooh telescopes in Chile to get a live view of the famous Horsehead Nebula. So this iconic cloud of gas and dust lies 1,500 light years away from us. And while it may look really dark, it is in the middle of cooking up some incredibly bright things. And so now we're going out live. We're going to be seeing that nebula. Absolutely incredible place because it's one of the places where star formation occurs. And because there is enough material floating around in those thick clouds to make brand new stellar systems like our own, it really is a very incredible hotspot in our universe. And we know this from looking closely at nebulae from all over our galaxy and studying them really carefully. And so, one way that we do this actually is by running simulations. So, for example, NASA actually ran a simulation recently of how stars might form in a cloud like this, where we're going to actually show you a video of how nebulae work in a simulation form. And oh yeah, there it is. It's popping up here. And yeah, we're seeing that video now. And so here we see. Uh, this is actually a video of the galactic simulations that we have of different galaxies coming together. We also have one where we're seeing a cloud of gas and dust as a nebulae that is swirling around, and sort of it becomes more than just a cloud of gas and dust. It becomes a whole sort of stellar system. And in that sort of in oh, here it is. Yes, this is the one we're talking about. So you see that there's different clouds right here of gas and dust, and in certain places, actually, that material is going to be clumping together. And so these clumps, what they're going to be doing is they're going to be forming new stars and planets. And each clump that we see, that's about the size of a solar system. So places like the Horsehead Nebula, they're much huger than what we're used to in our home. Many solar systems about our length, about our size, are really can be made out of this. It's a huge factory of creation. So this is not real. This is not an image. This is a simulation that we've made of this sort of event. So how does one go about making this sort of simulation? In the simplest terms, many points are put together in a computer model to form that cloud. The cloud that we see here that was becoming stellar systems. And these points, they're told to obey the laws of physics as we know them. We teach them about gravity, electromagnetism, motion, and all those sorts of things. And then we let time pass and we see that simulation evolve. And so if that simulation matches up with what we usually see in our own universe, when we look out in telescopes and we see things like the Horsehead Nebula, do our simulations, are they capable of creating things like that? Then we know that we did a pretty good job with our simulation. If it doesn't quite match up, then we have more questions that we potentially have to answer. And sometimes these simulations can even show us possibilities from phenomena that we can't see, things like black holes. But this is just one cloud that's forming lots of different interesting things, but it's just one cloud, nevertheless. Our universe is so much vaster than just one cloud of gas and dust. And so let's go a little bit further out into our universe. We're looking up at the Horsehead Nebula live from the Chile Slooh scopes, but we also have another object that's primed up on the Canary Islands scopes, a whole other hemisphere, a whole other slew of objects to see. This being the Sunflower Galaxy, it has this beautiful blossoming yellowish color to it, perhaps earning it the name Sunflower. And so this galaxy is very distinctive, quite a beaut, and it's 37 million light years away from us, so quite further than the Horsehead Nebula, which is right in our own hometown. But just like us, just like our galaxy, it contains hundreds of billions of stars, and some of them certainly in the middle of forming nebula, just like the Horsehead in our own Milky Way. And so we can also actually simulate the universe on this level. So NASA has a simulation of galaxies forming. We saw a little preview of that. And so there's a bunch of different galaxies that are just starting together in terms of merging and connecting and rushing about. We have a great video of that we can show you. And here it is. Yeah. So these pinpricks of light that we're seeing, they aren't stars. They're billions of stars together acting as different galaxies, and they're interacting with each other. We're seeing lots of different violent interactions here. They're pushing and they're pulling and they're merging over huge, gigantic time scales. Like, don't think this is happening 1 second or 2 seconds to 3 seconds. It's happening over millions and millions of years. And we see the center of the large bundles of light getting brighter as the galaxies form their central bulges. And this is really how the universe builds itself. It's an absolutely incredible process that we're simulating. This is not something we've taken a picture of. This is something that we've created within our computers. And we can actually even go bigger than this with our simulations. So researchers at the Max Planck Institute for Astrophysics, they ran what is called the Millennium Simulation. This is a really incredible one as well. This program actually used approximately 10 billion particles to simulate the evolution of around 20 million galaxies. And we can actually show you a very fixed point in time in this simulation. Here we are, we're flying through that simulation. This is bundles and bundles of galaxies. Each blob of light here is a galaxy, and the whole bunch together form clusters and superclusters of galaxies. These are highways, these are roads, these are routes. They're connecting together with different pathways. And this is modeling a region of the universe that is 2 billion light years across. This is huge stuff, absolutely huge stuff. And we're actually zooming in here on one of the more crowded intersections of this galactic plane. We have a bunch of galaxies bundled together here in a supercluster. And so we're seeing things on a scale so largely gigantic. And it's amazing to be able to consider that we can model our universe on these many different scales. We can approximate what occurs in gassy, dusty clouds like the Horsehead Nebula, and we can simulate the creation and evolution of a galaxy like the Sunflower Galaxy. And we can also simulate how all those galaxies look connected together on a universal scale, just like this. This is what we can do right now, today, in the present. This is not the future, this is now. And now, of course, there are certain things that we still can't quite simulate, and individual stars, all the processes in them being one of these things. But we're getting there in terms of being able to conquer all these different parts of our world. And so just imagine how much more we will be able to do decades or even centuries from now. Imagine where the computers will take us in that time. Just for some perspective, the Voyager spacecraft was sent into space 38 years ago, and it has a computer with 68 kilobytes of memory. Now, the modern day cell phone easily has tens of thousands of that amount of memory. We're in gigabyte land now, and that didn't even take us half a decade. And so the prowess of our computers, and consequently our ability to run more detailed and delicate simulations, gets better and better every single day. So, what if one day when we have the futuristic computers that far surpass the ones we have now, will we be able to simulate a whole entire universe? Could we create the very thing we exist within, down to the smallest atoms and the largest galactic structures? Well, some people actually believe that this has already happened. And not that we simulated it, but that we're the simulation. And that our universe itself is a giant, elaborate computer simulation. That, in a nutshell, is the simulation hypothesis. There are a couple of variations on this hypothesis, but the one that we're focusing on here today is the one that states that all of the particles, all of the stuff that makes us up, that's just like computer software. Like we tell the particles in our simulations of galaxies to obey the laws of physics, so does the computer running the simulation of our universe tell each quark and boson to obey the laws its programmer has in mind. So, this is a crazy concept. Whether or not you believe it, we can try and test for it to see if it's actually a real thing or not. Or we can try and test for it, at least. And so one possibility comes if the so-called programmer didn't quite program everything perfectly. Maybe these high quality aliens are making their own mistakes. If there are bugs in the code or glitches in the matrix, so to speak, maybe the laws of physics might suddenly change or not quite work right. And I don't think any of us have seen something like that pop up just yet. But let me know if you ever find yourself randomly floating above your bed or repelling magnets. Instead of being a new member of the X-Men, it could just be a software glitch in your code. Another possibility is one that is very relevant to the tech politics going on right now. So recently, the FBI was embroiled in a court case with Apple. And because the FBI wanted Apple to create a special backdoor into its iPhone products, that was the reason. This means if someone password protects their phone, and there is a backdoor in that phone, other people can still unlock that phone if they have the special backdoor key. So Apple was worried that if they created the backdoor for the FBI, other people could figure out ways to use that backdoor and hack into phones. Now, what if the programmer of the universe simulation programmed in a secret backdoor to our universe? If there was a backdoor, maybe we could figure out how to make a key to get to that source code of our own universe. So yes, we're going on really wild hypotheses and really crazy stuff. But that's what we do here on Down to Earth. We figure out what it is that's going on, or maybe what's maybe not. But however, perhaps one way that's a little more reasonable to prove or disprove a simulation could be as simple as figuring out whether a human being can be truly simulated. So we simulate galaxies merging, but can we simulate our own minds? It's a question of whether the emotions that we feel, the complicated relationships that we forge, and the dreams that we dream can truly be reduced to a set of computer data points. And we're working on testing that possibility as we speak. While they aren't quite laughing or crying yet, we do have some computers out there that are doing some crazy things. Watson is actually beating us at Jeopardy. In 2011, the computer Watson beat out some previous big winners of Jeopardy to take home the grand prize. So this computer isn't just beating the average human at trivia, it's beating the best of the best. And another example being very recently, the Google DeepMind project known as AlphaGo. It recently beat the top Go player. And that's just right out of the gate. This is with not a lot of playing other players. So these machines are already outwitting us. So would it really be so impossible for them to simulate our wit? I mean, I don't know. Uh, but what about looks too? There's a question of, can we simulate down to every hair follicle, every patch of skin ourselves accurately as human beings? And one way to consider it is when it comes to video games, we really do have characters and settings that look a little too real to be true sometimes. Like we have a screen cap of the hallway from the game PT, where you go around wandering within a house. And I don't know about you, but to me, that looks pretty housey. It's not an actual photo. It is the game. It really is. We also have a look at some characters from an upcoming Final Fantasy game, and they almost look like they could just be people. It's amazing where computer graphics are getting to in this case. So again, the original question, can one simulate humanity? Can that shiver that creeps down our spines when a particularly cold and unexpected gust of wind hits us really be reduced to a set of pre-programmed ones and zeros? Well, we don't quite know yet, but boy, are we working hard on pushing those limits to find out. And so, an interesting thought to consider, though, is a connection we've recently been able to make between the universe and ourselves. On the largest scales, where galaxies group among themselves to make clusters and superclusters, like we've seen in the simulation, the shapes that they form look similar to the connections in our very brains. Yeah, can you tell which image is of our neurons and which is of the universe? They look really similar, don't they? The neurons are actually on the left, and the galaxies are on the right. So the left image is measurable on the scale of millionths of a meter, while the right image traverses billions of light years. And yet, there are some striking similarities. And do these similarities in shape hint at similarities in form or in function? We don't know at this point. Perhaps they do, perhaps they don't. But perhaps if we figure out how to simulate a universe, we might be able to figure out how to simulate ourselves. Only time will tell, surely. But in the meantime, that has been our show. Thanks for tuning in. It's been some wonky concepts that we've covered, and I always appreciate you joining me on this journey. I hope to see you again next week for our next show. But for now, this has been Eric Edelman, and you have been watching Down to Earth. I hope you all have an absolutely wonderful good night, simulated or not.